All right, in this video, we're going to talk about the inverse trig in the unit circle, but our focus for this video is going to be tangent. So a couple of quick things to note before we start looking at some practice problems. I need to know that when I start investigating the inverse of tangent, actually, rather, it's not going to be theta. What we get here, we have to make sure that it falls within our bounds. Inverse tangent has the exact same bounds as the inverse of sine. So it's negative pi over 2 to pi over 2. So whatever answer we get when we start looking at the inverse of tangent, we need to make sure that it falls within those bounds, really just quadrant 1 and quadrant 4. All right. But probably the most important thing that we really need to be comfortable with is what the values are of tangent at each specific radian measure. So if you've never seen these before, I'm going to give them to you. That way, remember that tangent of theta is always sine theta over cosine theta, which in turn is the y value over x. What I am giving you is the simplified version of y over x. All right, I'm just going to go ahead and give you the value. That way it's very easy once we start working through our examples. So starting over here on 0, I know that point is 1, 0, right? Well, that's y over x. So here, that is 0. Tangent at 0 is 0. And as you progress through, I have root 3 over 3. I have 1. I have a root 3. And then up here, it's interesting, but my y value is 1, my x value is 0. When I do 1 over 0, we can't do that because we get an undefined value. So tangent at pi over 2 is undefined. Now, if you've seen my All Students Take Calculus video, everything is positive in quadrant 1. Well, all students, so the quadrant 2, it's sine and cosine, which means that tangent is going to be negative, and it just follows that pattern back down, but everything is now negative. Okay, and then we're back down to 0. So again, thinking through All Students Take Calculus, all students take, so in quadrant 3, everything is now positive again, and we just start building that same pattern back up, and then we get undefined down there at 3 pi over 2, and then that pattern decreases once more. And there you go. Those are your values of tangent at those given radian measures. And so now I want to use this to look at a few examples. So the inverse tangent at 0. Well, the inverse tangent at 0, when looking at this, is 0. That was easy. Now, what is the inverse tangent of root 3 over 3? So what I'm going to do is I'm going to find my value of root 3 over 3, and then root 3 over 3. And so here we have these values of pi over 6 and 7 pi over 6. Now, which one of those falls within my bounds here? Well, the answer is pi over 6. So we don't even need that one. So the inverse tangent of root 3 over 3 is pi over 6. Inverse tangent of 1. Well, again, there's two different locations that are going to give me a positive 1. But which one of those fall within my bounds? Well, that's going to be pi over 4. And finally, the inverse tangent of negative root 3. Negative root 3 we see occurs right here at 2 pi over 3. And we see that it occurs right here at 5 pi over 3. Now, we've got to be very, very careful because 5 pi over 3 is not in that bound. So there's a couple of ways that we can do it. If I think about going this way through those negative numbers, I know that that would be negative pi over 6, negative pi over 4. So that must make that negative pi over 3. Another way that you can do it is you can take 5 pi over 3 and we could subtract 2 pi so that we find the coterminal angle, simplify that out, and you still wind up with negative pi over 3. So whatever method you think would be the best for you, utilize that method there. But anyway, so that's the inverse of tangent, looking at the unit circle. I hope that this video helped. Kind of quick, but again, these are fun, these are easy. So hopefully now you feel a lot better with them. Appreciate you checking out the video. Check out my other videos dealing with sine and cosine inverse trig in the unit circle. If you have any questions over that, don't hesitate to reach out. So thanks again. I'll see you next time.